Hello, this is Dr. Eddie Morgan over at Clovis East High School. I want to walk through the Unit 7 review with you to help you get ready for the test. By the way, there's a special bonus to this review. I've added 2 questions at the end that are going to be on the test. I mean, not the same numbers, but similar numbers, and you just simply have to know them. So don't give up when we get done with the review. There's 2 other questions that will help you for the test. Good luck. In the first problem, we're asked to name 2 lines in the figure. All we have to do is pick one line and name any 2 points on that line and then use the double arrow symbol over the 2 letters. You'll notice it doesn't matter which direction the letters are written because the line goes both directions. So for example, if I pick this line, it has the letters A, N, and X. So I can pick any 2 of those letters. So I could put AX, I could do AN, I could do NX, and I could also turn them all around and have XA, NA, and XN. If I pick a different line here, my letters are C, N, and M, and so my possibilities are CM, CN, NN, and obviously the reverse of them all. And finally, there's the line that goes through the plane, and it only has 2 letters, so my choices are RN or NR. In problem 1b, we're asked to name 4 points that are not collinear. This means 4 points that are not on the same line. All right, so all we have to do is pick a line, and let's say we name 2 points on that line and then another point that is not on that line. So for example, here I have the points A, N, and X. So let me pick another point that's not on that line. My choices are R, C, or M. So if I pick any of these points, A, N, and R would, for example, would be an example of 3 points that are not collinear, and A, N, and C would be another one that's not collinear. I could pick a different line here, C, N, and M, and then I just have to add another point on the line, which could be A, R, or X. And so it's a matter of picking, you're just picking a couple points on the line, and then you just pick one point that's not on that line, and then the collection will not be collinear. One C is an unusual problem. It asks us to name 3 points that are not coplanar. Notice that any 3 points that form a triangle by necessity define a plane, so they're in that plane. So like R, N, and M, that's a plane kind of like a sail sticking out of the top of the plane V, but it forms its own plane. And of course any 3 in plane V, A and C, they're all in the plane V. So that might lead us to think that maybe if we could just find 3 points that somehow don't form a triangle. Well, the only way that can happen is if they're all on the same line, they're collinear. So if I look for a line, for example, there's a line, and I can say, okay, A and X, that doesn't form, those 3 points don't form a line. Likewise, C and M don't form a line, but that doesn't mean they're not coplanar, because you notice both of those lines lie in plane V, so all 3 of those points are also collinear. So we have to end up in this question concluding that we cannot name 3 points that are not coplanar in this diagram. Problem 1 asks us to name 3 different ways to name the line AN. Notice it has a double arrow indicating that it's a line. And there it is on the diagram. And remember, we can name a line because it goes in both directions using any 2 letters on the line and any direction. We got to make sure we use the double arrow symbol to make sure it's indicating that it's a line. For example, there's A, so I could name AN and X. Any 2 of those letters I can use. So I could use AX, or I could turn around and say XA. I could also do AN, or turn it around and do NA. And I could finally NX and XN. So there's 6 possible combinations for naming that particular line. Problem 1F asks us to state 4 different ways to name plane V. There's plane V, and the key here is all I have to do is name any 3 points in the plane that are not collinear. In other words, point R, by the way, is the only point I can't use because it's on the line coming through. It's not actually on the plane. So what I need to do is think about mentally forming triangles in the plane and then name the plane with these 3 letters. For example, here's a triangle in plane with A and C. So I could call this ANC. I could also call it ACN. The order does not matter, although lots of times we can put them in alphabetical order. And then I could pick another plane, for example, here. I could also name the plane as plane MNX. And it doesn't take much to figure out that there's 20 or 30 different combinations that I could make of triangles in the blue plane, as long as I don't use the point R, because R is on the line above the plane, not in the plane. Problem 1G asks us to name two opposite rays. We can begin this way by first finding a line with at least 3 points labeled on it. There's one with the points A, N, and X. Now let your middle point be the end point of both rays. Remember that both rays, to be opposite rays, have to have the same beginning point, and so it'll always be N in this case here. So we can have NA, which is the ray starting at N and going to the left, and NX, which is the ray starting at N and going to the right. We could have used a different line as well. For example, this line, CNM, and again, N's the middle point, so our rays would be NC, the ray going down, and NM, the ray going up. Problem 1H asks us about the location of different elements related to other elements in the drawing. The first one says, does point M lie on the line RN? Well, there's point M, and the line RN is the line coming in, and as you notice, it's not going to go through point M. So the answer to that one would be no. Point M does not lie on RN. Second one says, does point X lie on the line AN? Well, now when I draw IAN, notice AN does go through the point X, so the answer here would be yes, it does lie on that line. And finally, does point R lie on the plane ACN? Well, to look at the plane ACN, we need to, I'll draw a little triangle between them and look at the plane, and you'll notice that the actual point, the line RN, would touch that plane, but just the point R is not on that plane, so the answer again would be no. In problem 1I, we're again asked to look at different aspects and see if it's true. The first one is the line segment, notice it does not have the double arrow, so we're just talking about the segment, not the whole line, in the same plane as RN. Well, notice that I can actually form a triangle with AN and R, so there is a plane formed by that triangle that contains both the line segment AN and the line segment RN. So the answer would be yes. Those two lines, by the way, intersect, so they're obviously in the same plane. Let's look at the line segment CX and the line segment RN. Again, in this case, there's CX, and if I look at RN, notice if you look carefully at them, they're not in the same plane, because CX is in the plane V, the flat one, but RN is cutting through it and they don't intersect. So those two lines don't intersect, so they couldn't be in the same plane. The last one, the line segment AN, is it in the same plane as MN? Well, there's AN and there's MN, and you notice they're both on the paper V, and they both intersect, both lines intersect. So if the lines intersect, they're also going to be in the same plane. So that would be a yes for those two. In question 1J, we're asked whether certain segments and lines add up to other segments. Notice the first one, does AN and NX equal AX? Well, notice that the two all are collinear. They form a straight line. So in this case, we can use the segment addition postulate and say yes, AN plus NX is going to equal AX. On the second one, notice that CR and RM, one goes up and one comes down, and they don't form a straight line. So because they don't form a straight line, we can't say no that they add up to CN, because CM is actually shorter than those two. They form a triangle. The last one's kind of tricky because you notice the terminology change. Instead of asking what's the measure of the segment, which is when you ask that, you don't put a symbol above it, it actually asks, does the line CN and the line NM equal the line CM? Well, notice the line CN goes through C and N, but it's a whole line. It goes infinitely in both directions. Likewise, N and M is a line there that goes infinitely in both directions. And as a result, we can't add two infinite things. And so no, each line has infinite length, so we can't add the line segments to make other lines. We can only add line segments, not lines. The two of them actually, all three of those are actually the same line. Problem 2 states that point K lies on a line PQ and point L lies on a line TQ. Notice the two lines have a common point Q. John claims that all three of these points can be collinear, and Mary says that they do not have to be all collinear. Draw a diagram to support John and support Mary. Well, here's what John's thinking. John's obviously put P and Q and T all on the same line, so P, Q, and T are collinear. Now if I put point K onto PQ and I put L onto TQ, you can see clearly that all these points are on the same line and they're all collinear. So John's true that they can be all collinear. Mary, however, is recognizing those don't have to be the same line. In other words, PQ and TQ could simply intersect at the point Q and not be the same line. And now if we put in point K and L, you'll notice that they're not all collinear this time. So it's just different ways of viewing how PQ and TQ might be related. In problem 3, we're asked to find the distance or the length of a line segment. This is the same as finding the distance between the 2 points on a number line. Remember that distance is always positive. So mathematically, we would subtract the 2 points and take the absolute value. In this case, G is minus 10 and K is 2. So if I take minus 10 and subtract 2, I get minus 12, but the absolute value, because it's distance, is going to be 12. By the way, you could also start at G and just count over, and if you did so, you would find out that there's 12 units between them. B is for J and G. J is 0 and K is minus 10, so I have 0 subtract minus 10. Remember, however, that subtraction is simply adding the opposite. So I can always take any subtraction problem and change it into an addition problem, but I have to add the opposite of the other, and the opposite of minus 10 is plus 10. And so what we end up here with is we end up with positive 10. And so my answer here is 10. And again, you could count between G and J and find 10 units. HJ, H is negative 6 and G is minus 10. So minus 6 minus a negative 10. Again, subtracting a negative becomes adding the positive. So that becomes negative 6 plus 10 or positive 4. And again, if that's confusing to you, go to H and G and count 1, 2, 3, 4 between them. The length of HI, negative 6, subtract a negative 2. Again, subtracting a negative 2 becomes adding a positive 2. So negative 6 plus 2 is negative 4. And the absolute value of negative 4 is positive 4. The length of KG, K is 2 and G is minus 10. Once again, we're subtracting a negative number, so we can change that to adding the opposite or adding a positive. So 2 plus 10 is 12, and so the absolute value of that is positive 12. Remember, all the answers on this one are going to be positive. H and G, here we're finding the midpoint. Well, to find the midpoint between 2 points, we simply add them together and divide by 2. It's kind of like finding the average. So minus 6 plus 0 is minus 6, and so minus 6 divided by 2 is negative 3. And if you look up on your number line and find H and J, and you'll see if you tried to find what's the middle, minus 3 is the middle. So finding the midpoint between G and K, add the two numbers, negative 10 and 2, and divide by 2. And so negative 10 and 2 is negative 8, divided by 2 is negative 4. By the way, remember when we're finding the midpoint, we're actually looking for a number. We're not. Number 4 shows us a line segment made up of 2 line segments. And we can see that PQ and QR both go together to form the line PR. So what we're going to do is we're going to use the segment addition postulate. And the segment addition postulate states that PQ plus QR, the measure of each of them, adds up to the measure of the whole. And now all we have to do is substitute what we know about these. PQ is 3x plus 8, and QR is 7x minus 3, and they told us that PR is 45 units. And now we simply have an algebra problem to solve. So first, let's combine like terms. 3x and 7x is 10x. 8 minus 3 is 5. So we get 10x plus 5 is 45. We're back to our two-step equation. So undo the addition by subtracting 5 from both sides. So we get 10x equals 40. And now undo the 10x by dividing by 10, and we get x equals 4. Now be very careful on the test, because often in a multiple choice question they'll give you this answer, x equals 4, but we're not finding x in the test, although here we are finding x. To find PQ now, we're going to use the value of x and put them into the expressions for each segment to find them. So PQ now is 3x, or 3 times 4 plus 8. So that's going to be 12 plus 8, or 20. And likewise, QR is going to be 7 times x, or 7 times 4 minus 3, or 28 minus 3, which is 25. Now the great thing about these problems, particularly on a test, is you can check to see if they're right. Do those two actually add up to 45? And the answer is yes, 20 and 25 equal 45, so we know we got this problem. Problem 4b is a variation of problem 4a, and you'll see that as we put it together, instead of giving us algebraic expressions for the two short ones and the total length for the of the segment, they're giving us the total length of one of the shorter segments, but it works the same way. Notice that we're going to set up the segment addition postulate that says that the two short segments add up to the long segment, and then we're going to substitute in the values that we've been given. PQ is 5, QR is 3x minus 2, and RP, or PR, notice that you can write the segment either direction there, is 7x minus 9. So let's start by combining terms. We can only combine terms on the left side. 5 minus 2 is 3, so we have 3x plus 3 equals 7x minus 9. Now to solve any equation, we want to get all the variable on one side and the numbers on the other. So let's get all the x's on the right side. That'll keep them positive. So I'm going to subtract 3x from both sides. It gets rid of it on the left side and gives me 4x on the right side. And now we'll get all the numbers on the left side. So let's undo subtract 9 by adding 9. And we have 12 equals 4x. And our final step, undo the multiplication of 4 times x by dividing. The opposite of multiplication is division. 4x divided by 4. Remember to divide both sides to keep it an equation. And we get x equals 3. Okay? Now to find our different components, PR, we'll plug in x equals 3. So PR is 7x minus 9. So 7 times 3, or 21 minus 9, which equals 12. And then QR is 3x, or 3 times 3, 9 minus 2, which is 7. And how could we check these again? See if they add up to, if the two smaller segments add up to the other ones. So notice again, 5 plus 7 equals 12. Remember again that I put the 5 here because they gave us PQ as 5. And so we got this one correct. Problem 5 is a midpoint problem. It says that A is the midpoint of BC. So let's just draw that. Here's our segment BC, and A is in the middle. That means AB and AC are exactly the same length. So let's just mark what we know here. AB is 7x minus 9, and 5x minus 1 is the measure of C. Now because they're midpoints, those two segments are equal, so by definition AB equals AC. The measure of AB equals the measure of AC. So let's substitute in what we know, and now we just simply have an algebraic equation to solve. Let's move all the variables to the left side, so let's subtract 5x from each side. That gets all my variables on the left side. Now we have a two-step equation. So let's undo the subtract 9 by adding 9 to both sides. And now we simply have to undo the 2 times x by dividing by 2. And we get x equals 4. Now they want us to find BC. So what we're going to do is BC is the whole length. So let's find AB. AB is 7 times 4, 28 minus 9, or 19. We could at this point recognize that AC is also 19 and add them together, but just to check that we did our math right, I'm going to put in AC as well, and now they're both 19, so I know I did this problem right. If you're doing this problem on a test and they're not the same, you know you did something wrong finding X. And now to find BC, we recognize that BC is the sum of AB and AC, so we just add them together, and our answer is 38 is the whole length. 5b is a little bit of a tricky problem, actually a very simple problem, but a tricky problem because you're tempted to solve this the same way you did A, and it's really simpler than that. Notice if I draw this, AB, A is the midpoint again. They're telling me that AB is 7x plus 6, but they tell me that the whole length, BC, is 68, and they want me to find AC. Well, what makes this a little tricky is they've given you more information than you need. If you know that you have a midpoint, you know that AB equals AC, but you also know that AC is simply half of BC. So I don't even need to worry about the X part. All I need to do is realize that AC is half of BC. So what's half of 68? And the answer is 34. Problem 6 says that on a number line, point R is at -12, and the midpoint of the segment RS is at 5. They want you to draw a sketch and find the coordinate of the other endpoint, point S. So here is my number line. Point R is at -12, and the midpoint's at 5, right there. All I have to do in this problem is sort of count. If I draw this bracket here, I realize that go from -12 to 5 is 17. I mean, -12 minus 5, or 5 minus -12 is 17. All I have to do now to find the endpoint is just add that to the other side. So 5 plus 17 gets me to 22. So the endpoint, the endpoint of RS, or the point S, is at the point 22. Problem 7a asks us to look at the diagram and name angle 4 in 2 different ways. Well, there's angle 4, marked by the 2 rays there. And you'll notice that 2 ways we can name it besides a number is to name the 3 points that make up the angle, and always make sure that the vertex is in the middle of our name. So whichever way we name it, point P has to be in the middle. So my options are, you can either start here and go MPL, or I can name it angle LPM. I can reverse them, but P, the vertex, always has to be in the middle. Problem 7b asks us to name a pair of linear rays. This is actually not a good term. What we really mean here is name me a pair of opposite rays. Remember that 2 opposite rays form a straight line. So what we need to do is just find a straight line with 3 points, and we'll use the middle point as the end point of the 2 rays. Here's a ray starting at P going that way and going that way. Notice they form a straight line. So my answer here is PO and PL. There's another set here as well. If I use this other line, I have PN and PQ. Notice we can't use the line PM only because we don't have, it only goes one direction. There's one ray up, but there's not another ray coming down. Problem 7c asks us to name a pair of adjacent angles. There's a lot of them. We're just talking about angles that are next to each other. In other words, they share a common side and a vertex. And so any 2 angles that are next to each other, for example, these 2 angles here, I have OPN and NPM. Notice, by the way, that when you find 2 adjacent angles, they're going to have 2 letters the same because that's the common side. Notice these have N, each of them has an N and an O. But I can just go around now and I could name NPM and NPL. And notice I'm just going around clockwise, naming angles that are next to each other all the way around the angle circle. Okay. Problem 7 asks us to name an acute angle, an obtuse angle, a right angle, and a straight angle. So we simply have to remember our definitions and find them on the diagram. An acute angle is one that's between 0 degrees and 90 degrees, so it's smaller than a 90 degree or right angle corner. There's several of them. If I start over on the left, I have OPN, and then next to it NPM, and then next to that MPL, and finally LPQ. So I have 4 acute angles. The obtuse angle is an angle greater than 90 degrees but less than a straight angle 180, and there's one of those at the bottom, QPO. Then it asks for a right angle, which equals 90 degrees, and if you look at the diagram, there are no right angles there. So there's none in this particular diagram. And finally, a straight angle is simply a straight line. And so notice here there's a straight line here, which is OPL, but there's also a straight line there, which is NPQ. And so those are our straight angles, our acute angles, obtuse, and right angle. 7H asks us to name 2 angles that are congruent, and why? We're simply being asked to look at the diagram and from the diagram tell. We're not being asked to actually measure, because sometimes the diagrams are not exact. So the answer to this is that these 2 angles that I've listed, OPN is congruent to QPL, and why? Well, the reason they're Y is because they're what we call vertical angles. They're formed by 2 lines crossing, and the opposite angles are the same. So notice this angle and this angle are opposite when those 2 lines cross, and that's why they're called vertical angles. Problem 7I asks us to name 2 angles that are supplementary, and why? Well, to find a supplementary angle, we're looking for angles that form a straight line. And so I've listed 2 here, OPQ and QPL. They're supplementary because they form a linear pair, or in other words, they form a straight line. So notice there I have OPQ and QPL forming a straight line. And so that angle there is a straight line, so those 2 angles add up. There's another one. If I use the other line, I get these 2 angles as well. So there's actually two sets, 2 possible answers for 2 angles that are supplementary that form a straight line. Looking at the diagram, there's the angle LPQ, and they want to know what is point P. Well, point P is called the vertex of the angle. An angle is formed, on the other hand, that sides are rays. So notice each of them starts at P and goes out infinitely in both directions. So the sides of angle LPQ are called. 7L gives us some information about the different angles algebraically and asks us to solve to find what X is and find what one of the missing angle is. So in this case, first thing, I'm just going to label some things. Measure OPN is 4x minus 20, and angle MPN is 3x plus 14, and then the whole angle represented by the whole blue line is 162 degrees. Notice that the 2 smaller angles are going to add up and measure to the whole angle, and that's the basis for solving this problem. So we use the angle addition postulate to say that the measure of the 2 small angles adds up to the whole angle. Now substitute in what we know. So we know that 4x minus 20 plus 3x minus 14 equals the whole angle 162. So let's combine terms. 4x plus 3x is 7x. Minus 20 plus minus 14 is minus 34. Now we have a 2-step equation. Undo the subtract 34 by adding 34 to both sides. Undo the 7 times x by dividing by 7 both sides, and we find out that x is 28. Now they want to know what's the measure of OPN. So the measure of OPN is 4x minus 20, so I'll put in the 28. 4 times 28 minus 20, or 112 minus 20, and the answer is OPN equals 92. If you wanted to make sure that you were right on this problem, you could also solve for a measure MPN and make sure that those 2 add to 162. Problem 8 is one of those drawings that asks you to draw a diagram, because if you do, the answer is pretty simple. If I draw a diagram of CAD and then I have a bisector AB, notice the bisector cuts the angle in half. So it creates 2 congruent angles. In other words, the 2 angles CAB and DAB are equal to each other. Or another way I could say it is that either of these angles, like the measure CAB, is going to be half of the whole angle. Well, they told us above that the whole angle is 38 degrees. So guess what? The measure of the small angle is going to be half of 38, or simply 19 degrees. Problem 9 gives us two angles that are complementary. Now, complementary angles means they form a corner, they're 90 degrees, and they tell us that one of the angles is 30 degrees, so they want to know what the other one is. You can almost do this without seeing it, but if you draw it, it's really simple. There's my angle. Notice it's a right angle, and one of the angles here is 30 degrees. So if I recognize they're complementary angles, I recognize that the two small angles add up to 90 degrees, and substituting in, one of them is 30 degrees. So if I just subtract 30 from both sides, I find out that the answer is 90 degrees. And that ends the review. However, I have a special bonus for you today. I want to add two problems to the review that are essential for you to know on the test because of the last two problems on the test. So let's walk through these two, and you simply have to know these two formulas because they're worth quite a few points on the test. One of the problems you'll be asked to do in the test is to find the distance between 2 points on the coordinate plane. And an important thing to understand about this is you have to use, first of all, the formula, this complicated formula, x2 minus x1 squared plus y2 minus y1 squared. A couple of things to notice about this. It looks a lot like, there's components of it that are a lot like the slope. Remember the slope, you did y2 minus y1 divided by x2 minus x1. What you're actually finding is, in a sense, it's kind of like the slope in that you're finding the length. If you look at the diagram here in the bottom right, you can see that x2, x1 is simply the length of the bottom of the triangle, and y2 minus y1 gives you the height. Those are the slope, but they're also, if you use the Pythagorean theorem and say a squared plus b squared equals c squared, is the same as saying x2 minus x1 squared plus y2 minus y1 squared equals d squared. The distance formula is nothing but the Pythagorean theorem. So if you see the picture, maybe it helps you see where we're going. But for the sake here, let's simply plug in. Let's let m negative 17 be x1, y1, and z minus 114 be x2, y2. And if we plug them in, we get this. Now, the only tricky part in this problem is making sure, again, that you do the math right. Negative 1 minus 4 is going to be negative 5. But you have to remember again that 14 minus a minus 17, subtraction is the same as adding the opposite. So I can change any subtraction to adding, but then I'm adding the opposite. What's the opposite of negative 17? Positive 17. So in this case, you notice that you can end up being 14 plus 17. So we end up here with negative 5 and 31 squared. And now we use our calculators and square them. And so we get 25 plus 961. Add those together and we get d equals 986. So now we can break those down into prime factors to see if we can, I'm going to do this for fun, and I notice that they're all prime numbers. I can't go any farther anyway. So I simply take out my calculator and use the square root function and find out it's 31.4006. And so, as always, if we want to round off to the nearest tenth, here's the tenth. I look next door, it's a 0, so that's less than 5. So as a result of that, the other problem that will be on the test revolving around the coordinate plane is to find the midpoint between 2 points on the coordinate plane. Notice the diagram on the right. You'll notice that the midpoint between A and B is the midpoint of the x-coordinate is simply the midpoint between the x and 1. And x2. Just add them up and divide by 2. Likewise, for the upper part, the y, add the y. So there's your two formulas there. So all we have to do is say, okay, the x coordinates, add them together, negative 5 and 13. That's 8 divided by 2. And so the midpoint of that one would be 4. That's your x coordinate. The y coordinate, add the y's, 15 and 7. That's 22 divided by 2 is 11. And so the coordinates of the midpoint would be 4, 11. All right, I hope you do a great job on the test. It's 60 degrees.